So start with a nice, very pretty picture. I hope this is what you remember of the presentation. When you're looking at the Samsung member of the Talparo Formation, and we're going to take a regional perspective from all crops. So we're looking at the span from probably over a 10-mile stretch of the island. And typically, this is what our sands look like. Okay, our Talparo Formation traditionally has been subdivided into 6 members. Starting with the oldest comparable beds, Yunam sand, the comparable beds, Samsung sand, Chinchin clay, natural beds. So what we're looking at, a number of sand beds separated by clay stones, and this is how it was defined according to the legend. So it's underlaid and conformed by the Springfield, and conformed by the Cedrus, and there's a lateral equivalent that we're calling the Konaka. So let's start furthest east in the North Soledad Road Quarry. We're going to be looking at a whole series of photos which will attempt to build up a stratigraphic model. Very little writing. This section here is probably about 1,000 feet long. But what we're actually seeing is that we're seeing this very thin clay stone between the beds, and we're seeing excellent lateral continuity here. And if you have very good eyes, you can actually see some little prograding events inside of those beds. But this is the outcrop of the Samsung sand here, trending roughly north-south. Another part of the outcrop, and again, you're seeing pretty good lateral continuity. And what we see here is actually the edge of a big channelized system where a lot of the clay stone banks have collapsed into the channel. Something that you don't see too often, the very base of the Samsung unit, where we see, this is the underlying clay stone, and we see a zone of rip-up clasts where some big erosive event has attacked this and incorporated these sediments into the base of this sand. This is something we're going to be seeing continually every outcrop that we're going to be looking at. Now, from a log standpoint, if we do electric log, what we see with these sands is a very sharp base. You don't really notice these clays on a gamma ray log. If we start zooming in a little closer, what we actually start seeing are these laminae, all inclined, and generally what we see in all of the outcrops from west to east is that most of these laminae are inclined from west to east, suggesting that we have some kind of transport from west to east. Now traditionally, the literature says that all of this stuff came from the north, but let's go through all the photos and see if that is really true. What we also notice too is that we actually see graded beds within these massive sand units that are very difficult to pick up in gamma ray units. So there's a coarse, it's coarse at the base and it finds up here, so there's a coarse one finding up. And these are centimeters scaled here. And some of these laminae are lined by coarse quartz pebbles, very similar to what we find as a Konako conglomerate. And this is another close-up of it here. So this is what we tend to find at the very base of the sand, above that clay stone rip-up unit. Now, let's look back under the sand. Beneath the sand, within the North Soledad road area, you see this gray clay stone, and when it's unweathered, it's a kind of curious bluish gray color. When it's weathered, it turns red. But what we're seeing here, very abundant thalassinoides in these clays beneath the hard pan under the sand. And what you notice is that they tend to disappear the closer you get to the hard pan here. So these are the thalassinoides, and you see that they disappear going upwards. So it suggests that salinity or something is changing to cause these little critters to disappear. This here is a close-up of the base. This is actually beneath that zone of rip-ups. There's a hard layer which is made of iron oxides. But within this hard layer, we're also finding trace fossils. We're seeing food casts. And from these food casts, we can get an idea of some of the orientation of the currents that were transporting these sediments. And put here for scale, some tool marks, food casts, and centimeter scale ruler to get some fairly small features. It's unusual to find them. So close up the sand, you see things migrating. These are some of the claystones, the parallel laminate, but within these claystones there's always some little bit of sand ripples migrating through the system. Everything you see these faucets going through each of these beds. One is that these bands that we see here, basically I think represent zones of where water is moving through these sands and differential oxidation because of differences in the permeability of these sands. So we move about half a mile away from the last outcrop to the quarry at the Grisanko yard, and from far, this is what it looks like. This is just about half of the outcrop, but again, you can see beds are very laterally continuous even inside of here. So dominantly sand, and we start to get more clay dominated towards the top. But within here, you can actually see everything looks fairly parallel with it. So this is an excellent reservoir, and in one shot from that, this is a major freshwater aquifer. However, in the Gulf of Paria, there's one well, Iguana, that has encountered this stuff gas bearing. So in the Gulf of Paria, it could be a very important gas reservoir. Again, we're looking at closer up some of these sedimentary features. You see tidal bundles, you see big slump type features inside here. We need other flat events. So you get an idea of what we're looking at. We move now a couple of miles away into slightly different fashions, but again, same thing looks fairly constant. Mostly in a parallel bedding. And in this case, the differences in the color here are just differences in the amount of sun. So the lighter color stuff, 100% sun, the other stuff is a silt, and on top here we have clay. This same area at the base, you see these are clays at the base, and we see a zone of rip-ups here again. And lots of rip-ups. A close-up of what these sands look like, you can see toes coming down to the base of the bed here. And each of these is about a foot. Sandy View Road, this is one place where you can actually see the top of the unit preserved. Again, fairly plain and parallel. There are some very small faults in this outcrop. One of the things that you go upwards, you get less and less sandy. And above here is actually a zone of bivalves, which I have some photographs of here, and a little measured section. So dominantly sand, we see lots of sigmoidal bundles, and there's a very abundant monospecific bivalve assemblage at the very top of this unit. And it's the only place you actually find these bivalves, at the top of the Samsung. Windsor Park Quarry. Remember our crop, we were further down south, we were just gone a couple of miles to the north. This is one of the big active quarries at this point in time, so most of these outcrops are probably being quarried out by now. Again, you're seeing big planar parallel bedding units, but you can roughly see there's a big finding upward sequence inside of here. And some of the e-logs that we see tend to show blocky base and fine upwards towards the top. Got a rough measured section through here, and we're seeing all these sigmoidal bundles and things migrating through. In a big unit, it's planar parallel. In Windsor Park again, we've also seen these clear rip-ups. There's an iron, I call it a big concretion surface beneath these sands. Similar stuff, we're seeing fruit casts, we're seeing thalassinoides, very similar to what we saw in North Soledad Road. Again, we're also seeing here a lot coarser part of the faces. You can see these color differences. These darker units actually represent these very coarse, almost pebbly units. And what you're seeing here, dominantly two types of grain. Small white quartz pebbles and black lithic stuff. So it seems that a lot of this material we're getting here is originating from the northern range. That's a close-up again showing this big iron face surface at the base of the sand, and this is on the base of clays, and some small normal faults inside the clay. Temple Street, lots of sand again, mostly planar parallel bedding, and this is one of the geoscience classes for scale. There's a small rippled surface here. And this is just a basic columnar section at Temple Street. Rabin we visited here after the big flood event where the Talparo River overflowed and filled up the quarry. So we got an opportunity to visit here. And again, it looks very similar to what we've been looking at all the parallel bedding. And this here is actually one of the widest parts of the outcrop. And volumetrically, this was one of the bigger quarries. More close-up stuff. We're seeing big slump unit like what we saw similarly done by the sample yard, parallel stuff. And this is part of the reservoir that filled up the quarry to about an 80-foot depth. Basal contact, once again, great clay beneath the hard pan unit, and there's a coarse unit immediately above that. This is another little outcrop along the Solomon Poultry Highway at Forest Park. You're seeing some of the channelization, you see clay class liners, some of this there, you see laminations, and there's actually some nice channels here, and you actually see some clay-filled channels if you drive slowly enough in the traffic heading north. This is it here, so you actually see these big channelized units, sand-filled. There's a small one here. You can see some cut and fill within the section. Now, guy was clearing some land with his bulldozer and encountered a shell bed. And lo and behold, there was a big hole in the newspaper about Amerindian living and that kind of stuff. So eventually we went out and looked at it. Now what we found, these bivalves, I think I should have some names for them. So dominantly we see disarticulated oysters. These are what we call anadara. In the old days, these would have been arca or something. But what it is a little bed just under the sum. This would be inside a talparo clay. Now, these beds all lie within a very sandy, localitic unit, very different from the blue clays all around it. And we'll see how we can use that to build up a story. So, just to summarize all those pictures we've been seeing. This is Trinidad, this black thing, these are the Samsung outcrops. We started here and ended up here.
Channel.
Now, remember we were saying we're seeing lots of dipping laminae and beds and so on, which suggested transport from roughly west to east. We're seeing these coarse units with pebbles of quartz, lithic fragments, very similar to the northern range. And if you remember the initial stratigraphic chart, the lateral continuity with the Konapul conglomerates. So my guess is that we have these big fan deltas originated from the Korea Peninsula that are generating the Konapul. So you have these big events coming out, big flood events, cutting down the clays, pick up your clay ripple class. First you dump out are going to be those quartz pebbles at the base of the beds. Some of those fine upper beds we're seeing probably every time you get a big rainfall event out of the ranges down here into the littoral drift coming this way, winnowed by your Orinoco. Because what we're seeing is that roughly you're getting coarser from here to here because you're much closer to the source of these Konapul sediments. So with all of this, what are we going to see? Now within our section, what we're seeing is a Springvale. We have a sandy unit, we see these nice shell beds, but basically you see they eroded. So what I'm trying to do is to kind of relate these sand units to low stands of sea level. So this first Wilhelm sand is associated with unconformity. big drop in sea level, all the sediments out in northern parade out into the northern basin, Middle by Pilo, Orinoco, Penny towards the west. Some similar thing. One of the things we noticed that there are two some sands in the Gulf of Paria. There's an upper Samsung and a lower Samsung. However, this upper Samsung doesn't make it really onshore as far as you can see. It kind of stops somewhere midway within the Gulf of Paria. And that's it.